Okay, hello everybody. Welcome to class. I hope you are all doing well. Great to see you, and welcome to another wonderful lesson in Python programming. At Rate Africa, we want everyone to master Python. Python is a tool you'll be using in your career. You'll be using Python everywhere. And so what we want to do is to give you the opportunity to spend more time with Python, spend more time coding, spend more time getting familiar with Python, exploring Python more, and most importantly, getting hands-on with Python. And as you do that, the more you do that, the better you become. You need Python for data analytics and data science. You need Python for cloud and DevOps. You need Python for cybersecurity. You need Python for web development, software engineering. You need Python everywhere. And so it is extremely important that you study Python. Yesterday, in the data class, we were able to use Python to create our first machine learning model. And if you are new to Python, or if you are new to machine learning, I want you to follow our machine learning journey because we are going to do some very, very incredible things. And we are going to explore machine learning really well. We did a very, very basic model. And so if you want to understand it, the video is there. You can watch that lesson and get an idea of how machine learning models and AI models are created. And that will build the first step in getting into AI. Yes, so if you're interested in it, request for the lesson if you don't have it already, and make sure you watch it and follow our machine learning journey in the data analytics and data science classes. Every week, we are going to be having simultaneous classes. So cybersecurity students will be having theirs, as well as cloud, as well as dev team, and of course, the data team as well. So we are learning a whole lot, and we are happy to be here. Today, we want to continue from where we ended last week. And last week, we explored functions. Not that we've not studied functions before. Almost everyone here has been introduced to functions. But what we did was to go over functions. And the goal of this is to help us reinforce learning and also get familiar and be confident in writing functions, because we understand that functions are a part of every Python application. I've never seen any real Python application that function is not a part of it. Any serious use of Python, functions is a part of it. And I've seen how beginners learn. When beginners are learning, they are okay with writing if statements and probably for loop. But when it gets to functions and classes, then it looks a little bit difficult. Okay. But what we want to do is to take you back and help you get used to it. The way you are used to if statements and printing simple things with F strings. We want you to be used to it. Yes, and there are several topics that are very important in Python that we want to touch on again in a different way that will allow you to get a more practical feel of it, okay? A more practical feel of it. And so these particular classes, we don't want you to attend it by just watching. You have to be a part of the class because we are going to be coding along, okay? So don't just be watching the class. Make sure your system is ready, all your Python environments are set up and you are ready to write some code. Yes, I'm very excited to be here with you to take you through the next lesson in Python functions, because we are going to cover part 2 of what we studied last week on Python functions. I like this so much. And after this lesson, you will be able to define a function. You will be able to call and use functions effectively. This is part of our lesson 7 of our Python series, and we have covered a whole lot in Python. I want you to follow all the lessons and get proficient in Python. At the end of your journey, you should say that you are a true Python developer. Yes. And that is what we want for you. That is what we want for you. The most valuable asset can be your willingness to persist longer than anyone else. Those of us who have understood the secret to educational success and the secret to acquiring skills, we've understood that there is some persistence and some perseverance and some determination. And all those in this class who are applying them, I see them and I know them. I see the way some people are really learning hard. I see the way some people are taking things to the next level. I see the way some people are setting the pace. Some people are leading. Yes, I see it. Yes, so that is a key to success, especially to acquiring skills and learning and being the best. Okay, be willing to persist longer than anyone else, because when you pay the price today, tomorrow it will come in a lot of rewards. Okay, you will be rewarded for it today. And every effort we are advocating right now is just for your learning, it's just for your education, it's just for your advancement. So join us as we build a community of tech lovers, a community of skilled professionals, and a community of talented people who will change the story of Africa and make Africa great. Okay, so by the end of this lesson, you should be able to confidently define, call, and use functions effectively in Python. We started this last week, and I'm going to do a very quick recap of what we started last week. Now, before I get into the recap, I want you to tell me what a function is. All right. And in these classes, I want you to do things from memory. Okay. Do things from memory. From memory, what do you think a function is? What is a function to you? What is a function? So let me get 1 or 2 answers and we'll continue. I've not heard from anybody since I started speaking. And so let me be sure that I'm audible. Welcome, Ato. Welcome, Esimame. Okay, so Louisa says that a reusable block of code. That explains a whole lot if you understand it. Yes, a code block for specific tasks. A reusable block of, that's so powerful. If you understand it, it is so powerful. That is what a function is. So a function is a reusable block of code designed to perform a specific task. Yes, that is what a function is. Yes, thank you, Lucretia. Thank you, Newman. Yes, that is what a function is. And we talked a lot about it last week, about why it is important and why you should start coding in reusable blocks of code by writing functions and modules in your code. All right. So once you create a function works like a machine. And it is a machine that can receive an input. And once it receives an input, it produces the output it was defined for. But when the function is defined, Python stores the instructions and does not execute it right away until it is called explicitly. So when you define a function, the function doesn't do anything. It is just a machine you have built. Whenever you need it, you can just call it. When you call the function, then the function will come to action and the function will work. Function promotes code reusability, modularity, and simplicity. We talked a lot about this last week because it is a reusable block of code. The reason why we created it was because we can reuse it. We can reuse it by calling it as many times as we want. And it allows modularity because it helps us to write programs in modules. All right. So when we look at the syntax of a function, which we covered last week, this is just a quick recap. We learned last week that functions begin with a def keyword, a def keyword. Please type def in the chat for me. Type def in the chat for me. You see, the way you create your if statement by typing if, the way you create your for loop by typing for. With functions, you have to type def. All these are keywords, and the moment you type them, Python knows what you are referring to. Okay, if you say if, Python knows what you are about to write. If you say for, Python knows it. And if you say def, Python knows it. Now, it is very important that after you write your def, you provide what is called a function name. The name of the function is optional. What it means is that you can choose any name you want. The only thing you shouldn't do is to choose a conflicting name with a reserved name in Python. You know, Python has reserved some names, so don't create a function with the same name. For example, don't create a function called print. Why would you do that? Because we already have a print function. So any known function, don't create your function like that. Make sure your function is descriptive enough and it talks about what you're about to do. And then we also have what we call parameters. And then we also have the colon, very, very important. We have the indentation, very, very important. And then okay, so this one is called, who can tell me the name of this one? The comments we write in our functions. What is it called? The notes we put in our function. The comment we write in our function, what is it called? It's called a docstring. Please keep that in mind because as you advance, you are going to be hearing docstring. And if you don't think smart, you may not even get a context. But because you know that docstrings are comments in Python, you now use that to understand the context of what you are being told. So keep that in mind. It's called a docstring. And then your code blocks will come and then you are done. Now your block of code can be as many lines as possible until the task you want to perform is completed. All right. Sometimes when we are learning, we just use 1 line or 2 lines or 3 lines. But in the real world, your function may have several lines. Okay, so there is no limit. It's all about completing an operation. Yes, so you can write as many lines as possible. What is important is to keep it indented. We created a function with no parameter, very, very easy. We created a simple parameter function called greet, and then we just printed something. And then we called it. We called it. So when you call it, you just type the function with the parentheses. And these parentheses are very important. It is 1 sign in Python that lets you know that you are dealing with a function. You are dealing with a function. It is a sign to let you know. So if you are creating a function or defining a function and you will not even use parameters, then you have to, not even then, you definitely have to provide the parentheses. Okay, whether you will use parameters or not, you have to provide the parentheses. You can also create a function with a single parameter. We tried that last week. We were able to do that, and it means that you need to provide an argument whenever you call the function. Let me reshare my screen so that I can do some drawings on the screen for you. Okay. So over here, we can see that the function was defined with a single parameter. And so whenever you are calling the function, you have to make sure that after calling it over here, greet user, you need to provide this argument. If you don't provide the argument, it's not going to work. If you don't provide the argument, it's not going to work. So you have to provide the argument. Very, very important. We also discussed functions with multiple parameters. Wow. So when we say multiple parameters, what that means is that you can define a function with a specific number of parameters. All right, so we tried this last week to perform a calculation. We requested for the total, sorry, the price and the quantity, and we produced the total. And so over here, we use two parameters. And so when you use two, you have to call the function with two arguments as well. All right. Now, when you use two parameters, can you decide to provide only one argument? Yes or no? I'm asking a simple question. When you define a function with two parameters, can you call the function with one argument? Yes or no? The answer is no, 1,000 times no. All right. So if you define the function with two parameters, it is compulsory you have to provide two arguments. If you use 3, 4, 5, you need to provide the same number of arguments, unless, of course, you are dealing with the default parameters, which we learned last week, and some of you still remember. With the default, you can create a parameter and assign a value to it. That value is a default value. What that means is that if the caller does not provide a value, then the system will use the default value. And so during the call of this particular function, you can see that this person provided an argument and it worked. But this person did not provide an argument, and guess what? It also worked because the parameter that was used, called subject, had a default value or default argument. All right. In terms of parameters and arguments, parameters are variables and arguments are values. All right. So it had a default value. And so even if you don't provide, it works. We tried another example where we used two parameters. One was having a default, one was not having. And we called the function and provided only one and it worked. We also provided two and it worked because the second one had a default parameter. That means if you provide the value or not, it will still work. All right. This is where we got to, and this is where our new lesson begins. You were given an assignment to practice, and through that practice, you are going to be familiar with Python. Now, what I want to urge you very, very seriously is that you need to make sure you practice the assignments and the homeworks you are given. Make sure you try them without getting help. Make sure you try them without getting help. Make sure you are part of the lesson and you are understanding. If you have questions, please let me know. Wherever you got lost, you can draw my attention to it and I will go back and I will explain it again. Make sure when you are giving the assignment, you do them. Some of you sent in your assignment, some of you have not sent in your assignment. You need to send it and make sure you do it without getting help. I want to find out who was able to complete the assignment without getting help. Who was able to do that? Let me see in the chat. Anybody who was able to complete it? All right. So we have Robley, we have Mike, we have Lucretia, of course, Lucretia, Oluwafemi, Isaac, Bernardine. Okay. He said, I'm so proud of myself. Israel, Jacob, John, Hillary, Robin. Okay. You are heroes. Okay. You are heroes. Listen, what we are doing here, we are not here to impress anybody. We are not here to submit anything to impress anybody. We are here because we want to train our brains. We want to teach ourselves. You know, if you are not used to these things, your brain needs more data, more information to be able to understand it. So when you get opportunity, don't give it to an AI. Hmm? Last time I was saying that instead of doing machine learning, do human learning first. Your brain needs more data to understand these things. So if you get the opportunity, feed yourself, feed yourself, feed yourself. Nobody is watching you. Okay. Don't be interested in impressing anyone with your answer. That is not why we are here, because AI can do all of these things in a second. That is not why we are here. So you need to put it aside and train yourself, because this is for your career. This is for tomorrow. This is for tomorrow. Yes, and it will help you be able to read code. It will help you to be able to write code. It will help you to be able to solve important problems. If you don't train yourself, you may miss out on important things later on. And the benefits that others are getting now, you may get very little if you push the work to an AI. All right. So today we want to move to another level where we create functions with star args. Please type star args in the chat for me. Star args. We call this flexible argument. Flexible argument. All right. You can create a function with star args. This should be normal. It's just another way of creating a function. Now we know that we can create a function without a parameter and it will still work. We know that we can add as many parameters as we want, and they need to get their arguments before they will work. We have understood default parameters. We are okay at that level. At this particular level, we have the ability to create a function and make the arguments flexible. What this means is that the star args allows us to pass any number of arguments to a function. What that means is that instead of stating that you need two parameters or two arguments, just use star args. If you use star args, and you need to know when to use star args is an open function. And what it means is that the user or the caller can provide any number of arguments. This means if I provide 3 arguments, I'm not going to get wrong. If I provide 2 arguments, I'm not going to get wrong. Let's try it and see. So let me open to PyCharm right now. And let's define a function with star args. So over here, let's create a new Python file and let's call it flexible, or let's say functions with flexible arguments.py. All right. Now to define a function, nobody should tell you that you need your def and you need a name. So this function, how should I go about it? Let me just give it a name, like let me call it my numbers. And the argument or the parameter I'm supposed to create, I can say star args. This is what we are talking about. Star args. So instead of saying price, comma, quantity, this is very restrictive. And it is also important for the specific use case. But sometimes we can use star args to say that this particular function can accept any number of arguments. Let me return the results. The results should be the sum of args. I'm done. Sometimes you can create a function with just one line of code. And that one line is doing multiple things. Let's see what happens. The function is called, so here, let's say calling the function. The function is called my numbers. So I say my numbers. Then I can say 1, 2. Okay, 1, 2. Now, when I say 1, 2, let me store it because I'm returning, I'm not printing. So let me store it as the total. All right, because I use sum here, let me call this total. So I'll say the total is, I'll print f strings. The total is, then open f strings and say total. All right. So when we run this, we are going to see that the total, what do you see as a total? Okay. So someone says, I see 3 as a total. Okay, wait a minute. Why not we add 5 to it? Let's just add 5 to this. Let's run this and see. The total is 8. Really? Let's add another 2. Okay, maybe 3. The total 11. Okay, now let's add 4. Total is 15. Let me add 10. Wow. This type of function is magical. I like it already. It is magical. Can you imagine how this function is working? First of all, this function is not saying that you left one positional argument, or you are supposed to provide 2, or you are supposed to provide 3. What do you think I'm doing here? Who can tell me what is happening here? What do you think I'm doing here? Who can tell me what is going on? Who can tell me what is going on right now? You provided multiple arguments, yes, but what is happening? What is happening here? Summation. Summation is happening here, but what is going on here? You are adding. Okay, fine. Adding the numbers. I'm not adding. I'm just providing arguments. I'm not adding. The adding is being done by this function. This another function. All right. Now, what is happening here that I want you to see? I wish someone had just said it. There is no limit to the number of arguments I can provide. This is not how normal functions work. Look at what is happening. This is not how normal functions work. Functions are very strict when it comes to the arguments you are supposed to provide. I'm talking about what I'm adding here. Functions are very, very strict. If a function is defined with one argument like this, you cannot call it. It says that this function takes one positional argument, but 8 were given. Functions don't play with their arguments. If they ask for 8 arguments, you have to provide 8. If 5 parameters are used, you have to provide 5 arguments. But this time, something is going on here. I just use star ask, and Python says, I don't care anymore. You can provide as many arguments as you want. That is what is happening here, and that's what I want you to see. Now, we are going to learn what happens whenever we use star ask. I just demonstrated it here for you to see it in action. Over here, what I did was to call another function that already exists in Python. Python has some pre-existing or inbuilt functions that you can use. So anytime in future that you are asked to define or sum a number of integers, you can just call this and provide the list or the sequence of integers in the parentheses here, and the sum will sum it. All right, we'll come back to this. Come back to this. Now, the star ask parameter in a function collects all positional arguments and pass it, collect all positional arguments passed to it and stores them in a tuple. Okay, so what this means is that anytime you use star ask, you have defined a function with an instruction not to limit the argument, not to limit. To be sure that you understand, if I provide only 2 arguments, will this code work? Yes or no? Will it work? If I provide only 2, will it work? Okay, yes, it will work. Okay, let's try it. And it works. Okay, fine. What if I provide only 1? Will it still work? Okay, let's run it and see. What if I provide nothing? Will it still work? Wow. I think this is an interesting way of defining functions. Nevertheless, you need to know when you will need it. Okay? You need to know when you will need it. You need to know when to use it. Look at this. This is so powerful. This is so powerful. Now, most of the time, when we use star ask, we get a sequence. So this becomes a variable. That is a tuple. We just learned that it's a tuple. So all the arguments you provide will turn into a tuple, and the tuple will be here. Right now, this particular code is performing multiple functions. It is possible, this alone tells you that you can call one function within another function. Let me repeat that. You can have a function, and during the block of code, you can call another function. We call that nesting of functions. Nesting of functions. You can call one function within a function. That's what I've done here. All right. But most of the time, we use things like loops to deal with what we have here. All right. Let's continue. Okay. Now, the name ask is just a convention. You can use any name, but the asterisk is required. So anytime we say star ask, what it means is that the asterisk is very, very important, but the name you provide here is open. Just that in the Python community, most people call it ask, and it has become a convention that everyone uses. It's a naming convention that everyone uses. So most of the time, we just call it star ask. This is not to say that if you say star numbers, it won't work. It will work. All right, it will work. Let me put it here again and let's run it. It worked, no error. So the name here doesn't matter. What matters is the star. You can put Robly, and put 1,3,4. Let's see if Robly will work. Okay, Robly worked. Okay, so this means you can use any name at all. All right, let's continue. Yes, Robly worked. Isaac says, what if it's only star? But you need a name, so how will you refer to it? You can see what is happening here. When you say star, you give an instruction to the function, what you're about to do, but the values have to be stored somewhere. You can see how I'm receiving the values. You see, Isaac, you can see how I'm receiving the values. So if I don't provide a name as a variable, how will I receive the values? You see, and most of the time we use it in a loop. So later you see that we'll use this in a loop and we need to get a name. All right, so over here, we have a simple Python code here that is supposed to list items. And we want to see how the star axe works. And over here, it says the function is called list items. Star axe, we know what it does. And we have a print that says item list. Then a loop here that will print the items. And then inside the loop, we'll just do a printing of each item. All right, then when we call it, we need to provide the items. In my previous example, we used numbers. All right, this new example here says we should define a function called list items. And we have star axe. Over here, you close it. All right. Now, this particular star axe, all we want to do is to just say print, and we will say items list. Is it items list column? All right. So this items list, what it means is that it is going to be just a heading. Okay, that's why we printed it first. Then we create a loop. Now you know that this becomes a sequence. So you can say that for item in axe, this is how you create a for loop. You don't have to use item. Item 2 is open. You can say for arg in axe. For anything in axe. Axe is now this variable. You can see how it has lit up here. Then in here, let me just call it item, or let's call this thing items. So next time when you see this, you understand it. So we can say for item in items, then print in f strings dash item. All right, so this is a simple for loop within a function. So later, when we call this function, the name is called list items. And you can see that this function, it prints, it doesn't return. So we can just go ahead and use it. And it needs a list of items. Let's provide, please give me some items to use. Give me some items to use. What can I use? So we'll follow what the first person gives us. Gary, hey, what is Gary? Gary and bread. And then fish. And then fruit. Thank you, Timothy. And then milk and egg. Eba. Ebe. Okay, so milk and egg will be fine. All right. Okay. Now, are we allowed to add more items? Are we allowed to add more items? Yes or no? Are we allowed to add more items? Yes. Now, one person should tell me why. Why are we allowed to add more? Because we remember functions to be so strict with arguments. That is actually what I was referring to. Okay. But I got an idea with what you said, Robley. Because of the star items, or because of the star, because it's flexible. I like that. Because it's flexible. Thank you. Thank you. All right. So let's run this and see what happens. So you can see items list, and then all our items will loop. So most of the time, anytime we use star arcs, usually we use it with loops because we know we are getting a sequence. You see, anything you will loop is called a sequence. A sequence has a sequence has a sequence. Watch this. A sequence has multiple items. So you can loop over a sequence. So anytime we use star arcs, whatever we get becomes a sequence. And we just learned today that it is a tuple actually. So it is a tuple and we can just loop over it. So it will be stored in this variable and we can just write a for loop. Okay, a for loop. This is just f strings. The dash here is just a decorator. I can change it to anything, asterisk, it will work. It's just to just show the bullet points. That's all. It's just a bullet. That's all. Now, if anyone is lost, let me know and I'll go back and help you. Now, listen to what Robley said. Robley said a list and okay, Robley said we should try the list one. Okay, so please watch something, okay? If I don't use star and I just say items, can we provide multiple items? Yes or no? As arguments? Okay, now watch this. When we run this, we know we'll get an error because it takes only one, but we provided six. Now, watch this. This is what Robley said. What if what we provided is wrapped in what is called a list? Watch this. By doing this, everything we provided has been put together as a list. Listen carefully. Can this list be assigned to just one variable here? Yes or no? Can this list be assigned to just one variable here? Okay, I'm getting two yeses. Okay, 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 I got more yeses. Let's run the code again and see. What? So you can see that we have discovered something so interesting, and this is so nice. Thank you, Robley. This is so interesting. This means that although we are not using star arcs, we can put unlimited number of items in a list and provide it to just one variable, and it also works. Okay, so this is another way of thinking about it. That's wonderful. This is so interesting. I'm loving it. All right. Okay. Now that we have explored this in multiple ways, I'll say anything. I'm going to give you a challenge. Uh-oh. I think we have solved this. But I want you to write this function for me. I want you to create a Python function that takes any number of arguments and returns their sum. I'm giving you 3 minutes. I want you to solve this. Please think critically and solve it. And then take a screenshot and put in the chat for me. I'll only mark for those who do it. So I'm giving you 3 minutes. Just create a function now. Provide any number, okay? And then return their sum. Okay, this is under the topic of star arcs. So I'll be happy if you use star arcs. And then post your answer in the chat for me. I'm giving you 3 minutes. So let's start now. All right. So you've done very, very well. Okay. Wow. That's nice. Thank you. Lucretia, your code is very clean. Wow. Wow. I like that. I like that. I like the quality. Okay. I've been waiting for Bernardine. I was wondering when Bernardine will show up. Okay. Okay. All right. That's beautiful. Well done. Let me see Isaac. Okay. All right. So I'm happy we have seen how star arcs works, and we've also seen how to call other functions within it. So we've tried this already, so I'm not going to do anything about it. So you all got it right, and it was the first example we tried. All right. Let's take challenge 2. We are going to take 3 challenges. Now, the next challenge says write a Python function that takes any number of arguments and returns the largest number. Returns the largest number. So this, I think you can do this in less than a minute if you know what to do. So let me give you a moment to think and see how you go about it, okay? So what we are saying is that take any number of arguments, but pick the largest number. So if you provided 1, 3, 5, 8, 3, 2, the largest number will be 8, okay? So this is our second challenge. Let me see how you go about it. Let me see how you go about it. So just a minute. I want to allow you to think and solve this. Okay. So I'm super excited how you are all nailing it. You've all done very, very well. I think everyone has done the right thing. Wow. Some are more elaborate. So this is very, very simple. Just like the code we wrote before, just like the previous program we wrote. So def, let's call this largest number, and we use star arcs. Then we will return, this time instead of the sum, we return the max of arcs. That's all. So when we call the function and we say that let's call this okay, what did the question say? It's the largest number. Okay. Okay, so let me call this largest equals to largest number, and we provide the numbers. All right. And then we can just print the largest. All right. So let's see if it works. and the largest is 6. So if we check here, 1, 3, 5, 5, 6, 4, 2, 4, 3. Let me change this to 8 and see if we'll get 8. All right, so these inbuilt functions will be useful later on, and I know why I'm introducing them now. So it helps you to find specific calculations from a sequence. All right, so I think we are clear with this. Let's move on to challenge 3, which will get us thinking. Now with this challenge, it says I write a function that takes any number of arguments and returns only the even ones. I want to see the first person who can post this. And please, right now, we are very, very honest with our studies. So what I mean by that, we don't tolerate any AI. So think and solve this. I want to see the first person or the first 3 people who can solve this. I'm giving you 5 minutes. First 3 people. Think about the question and solve it for me. Okay, so I've seen that most of you have solved it impressively. Impressively. You've done very, very well. Very, very well. And I can see some ChatGPT as well. So shout outs to all those who didn't use ChatGPT. Shout outs to all those who didn't use ChatGPT. All right, so let's review the challenge and see how we will handle it. Okay. Some people didn't understand the question. All right. So it says that write a function that takes any number of arguments, you understand that, and return only the even ones. It didn't say return only the even one. It said the even ones. This means that if there are 3 even ones, we want to know them. If there are 4, we want them. If there's only 1, no problem. But you cannot control the number of arguments that are provided, because once you create the application, anyone can use it. All right, so let's solve this quickly because of time. So let's give it any name. Let's call it even numbers. Okay, let me not call even numbers here. Let me call it the function list of numbers. Okay, list of numbers. And we use star args here. And then to solve this, one of the first things you need to do is to create an empty list. All right, so to create an empty list, we can call the empty list even numbers, and then we make it a list that is empty. Now if this list is empty, what it means is that we can always append something to it. Now it is very simple. We can loop through the numbers. So let's loop through the numbers. To loop through the numbers, we use a for loop. So we say for number in list of numbers. Sorry, for number in args, because the numbers are stored here. So for number in args, this means that when it goes through the list, each number in each iteration will be stored in this variable. So we can run a check on this particular number here. So we can say that if this particular number Who remembers modulo? Modulo 2 equals to 0. Then, is it an even or it is odd? Is it even or odd? All right. Okay, thank you. Sorry. Okay, so if modulo 2 is equal to 0, is it even or odd? All right, so it is even. So if it is even, then we can call our variable here the empty list called even numbers, and then we use a method. Now, these particular methods, they are the reason why we want to revisit Python, because there are some important methods that we need to pay attention to. When it comes to strings, there are a lot of string methods that we need to remember because most problems are solved with them. All right, so we need to append the number to it. So now watch this. This is creating a loop over the args or the numbers we received here. Instead of calling this args, we can call this numbers. And here we can just say numbers. It also works. During the loop, we'll pick each one and check whether it has a modulo 2 of 0. If yes, then we append it to the empty list here. Now this append, what does it do? In case someone is not following. This append, what does it do? It is a method, it's a list method, it will add. Okay, so watch this. When we started, we created an empty list. We said we have a list, but be empty, nothing should be in it. Thank you. Then here, we will run our checks. If we find an even number, then we will add it to the empty list. At the end of the day, we will have the empty list. At the end of the day, we'll have the empty list. So what we can do is to tell the Python function to return the list. Okay, we can tell Python to return it because whatever is in there will be the even numbers. So now let's call the function, and let's call the function, it is called list of numbers, and we can provide any. Okay, now when I said list of numbers, you could have also used a list to collect this, but I meant for you to use a star args. All right, so it will return the even numbers. So what we can do is we just print this, or we can just make this print. We can just print this here. Then this should be working. So let's run this, and we can see that the even numbers are 2, 4, 6, 8. This is so wonderful. So you don't control the number of arguments that are provided. You don't control the numbers that are provided, but your job is to always append to an empty list and then print that list after the loop. So after the loop, it means we've gone through all of them and the odd ones were left out. All right, so what if I change my mind and I say that I want the odd numbers? What do I do? How do I tweak the code to get only the odd numbers? Who can tell me? How do I get the odd numbers? Anybody? I'm sure everybody can solve it. How do I get the odd numbers now? Okay, so modulus 2 equals to 1. Thank you. Thank you, Bernardine. Thank you all. So let's run it again, and we get the odd numbers, even though our variable is saying even numbers. All right, so this is done, and that is it. Now, practicing these things, you may not see it, but you are learning. We'll try one more star axe, and then we will take the last type of parameters, and then we'll be done with this particular lesson. Now, it says that using star axe with other parameters. What does it mean? You can make star axe with other parameters, but anytime you do this, star axe should always come last after the normal parameters. What does it mean? Look at this code here. Very, very interesting code. It means it is saying that you can use a normal parameter and also provide star axe. That is so interesting because star axe can still be anything. So how do we know which one is this? We know, for example, when we call it, we know which one is this one because of the position. These are positional arguments. All right. These are positional arguments. So the first one will go to this parameter, and then the last, all the rest will be stored here. Okay. So if you understand what we are talking about, we are saying that you can use star axe, all right, but you can also add a normal parameter before star axe. This looks a little strange, but it also works. So what we want to do, just like we have here, is to create a for loop to print the greetings for everybody. So here, instead of ask, let me call it names. And then I have a message for everyone. So over here, we can say the for name in names, print f strings, print the message, and then you can use comma or not. And then you can also call the name. All right, so this is a beautiful program. And when you call it, what this means is that when you call greeting, is it greetings or greeting, or whatever you call it? When you call greeting, your message should come first. Maybe welcome. Then over here, I see Amon, and then I see Timothy. I see Valentine. I see Esimame. Esimame. And then I see Marianne. The Marianne. Okay, fine. So over here, you can see clearly that PyCharm is telling you that the first one is for this variable, and then all the others belongs to star axe. Okay. So when we run this, we are going to see that welcome Amon, welcome Timothy, welcome Valentine, welcome Ismami, and welcome Marianne. Now, this doesn't make sense to you. Does it make sense to you? Does it make sense to you? Okay, Robly says yes, it makes sense. Okay, all right, all right. Because the idea of star axe is for you to provide multiple, arguments. But over here, we have a normal argument and then the star axe. And this is very, very interesting because star axe doesn't have an end. So how do we know what is for this? You have to understand that the first one, the first argument will be assigned to this. This means that you can have another variable. You can have another variable. Let's say, let me call it salary. You see what happened? When I said salary, PyCharm assigned a second argument to salary, and then the rest to StarArcs. So this is very interesting to take note of, and I'm sure you get the idea. All right. So because of what we are learning, I'm going to take a short break. This is the last topic. It should take us about 15 minutes to finish. But let's take a short break, and then we will come back and learn about the quacks. The quacks. The quacks. And it wouldn't have been good if we had ended all last week. So we want to wrap it up, and we will always do our best to use functions in everything we do. All right, so let's take a short break. Usually we take 10-minute break. So let's get up and stretch, and then we will come back and finish the lesson. Thank you very much. All right, so welcome back from the break. I hope you were able to get up. I want you to get up and stretch when the lesson is more than 1 hour. All right, so we want to wrap up and talk about quacks. And these quacks, it is not just called quacks, it is called the same way we call StarArcs. This is double star quacks. And in the first one, we're made to understand the importance of the asterisks. Python allows you to create functions with double asterisks, and it is popularly known as quacks. If you can hear me, please type the quacks in the chat for me. Type quacks. Now, the quacks is just short for what is called keyword arguments. So previously we did args. Now we are doing quacks. The quacks is just keyword args, keyword args, keyword arguments. Now we remember when we created functions that already had values. We call them default parameters. The quacks is short for keyword arguments, and it allows you to pass multiple keyword arguments to a function. Now, what is meant by a keyword argument is an argument that has a keyword, or an argument that has a variable, or an argument that has a known or a named parameter. The double star quacks collect all the keyword arguments passed to the function into a dictionary. Now, this should take your mind back to default parameters. That's all we are talking about. Those default parameters, they are the same thing that we are referring to as keyword arguments. And so those parameters already have their values. And so there are some times that when you are receiving them as arguments, listen carefully, they may require you to state the name of the parameter or the variable. This is why we call them keyword argument, because they are arguments with keywords. And we use the double star quacks the same way we use the StarArcs, but this time it is meant specifically for the keyword arguments. So each key in the dictionary, and what we mean by dictionary is that when we collect the keyword arguments, what happens is that we store it in a dictionary. Python automatically stores it in a dictionary. And then the key in the dictionary corresponds to the parameter name, and the value corresponds to the argument value. This is used when we don't know beforehand how many named arguments might be passed to a function. So for example, just look at the bottom here where we called the function. Let's start from there. You can see that most of the time when you call a function, you call it with an argument like Alice. But this particular type of function, we didn't just call it Alice. We actually added the name to it. Or we actually quoted the parameter and then we called it. This is quite interesting. Let's see if this will work over here. Let me convert this to a single name. All right. And I'll call it later. Let me convert it to a single name. And we will just say it should print the message and the name, no for loop. Okay, look at this function here. Look at this function here. Is it saying that when you call the function greeting, you can actually say message equal to hello and name equal to Danai? Is that what it's saying? Let's run it and see. Let's just run it and see. Let's run it and see. Let's run it and see. It worked. Wait a minute. Just wait a minute. This means that if you have a function with parameters, you can just go ahead and provide the arguments. Or you can add the parameter to it. If you know the parameter, you can call the parameter specifically and assign it to a value, and that value will represent the argument. So we call this named arguments. So this one, I need to add this to it like this. It works. All right. Now, sometimes we want multiple named arguments like this, but we do not know how many we will want. Okay, we do not know how many we will want. And so Python is saying that, okay, just use the double star and quacks. If you say double star quacks, this time you cannot just go ahead and say print message because something happens to it. Anytime you call double star quacks, Python is ready to receive named arguments. Just that it doesn't have a limit like what I did previously with message and name. My question is, what happens to the double star quacks? Because I said that something happens to it after you define the function. Something happens to this. What happens to it? If you know what I'm talking about, what happens to it? I just mentioned it over here. What happens to it? What happens to it? Okay, thank you. And so the data that you provided, both the keyword and the arguments, they are collected and converted into a dictionary. So anytime you use the double star quax, it means that you have to deal with a dictionary. It becomes a dictionary. Thank you, Benedine. It becomes a dictionary. All right. So over here, let's see how we handle the dictionary. You can see that with this, you are free to provide as many keyword arguments as you want. And you can see it clearly that we provided name, age, country. You are not restricted. You can provide whatever you want. The double star quax makes room for that. The only thing is that when it collects age, name, country, or whatever you add, it will turn it into a dictionary. Please type dictionary in the chat for me. Type dictionary in the chat for me. Thank you. And so what you have to do when you are processing that data is to process it as a dictionary. That's all. However, we manipulate dictionary, that is for your knowledge in dictionaries. You can loop through your dictionary. You can pick only the values. You can pick only the keys. You can do whatever manipulation you want. It is now a dictionary. Whatever you want to do, you can go ahead and do. So over here, let's do what this code is saying. We are going to create a loop in a dictionary. And you know that dictionaries, to loop in a dictionary is a different story altogether. All right, so you have to say for. It's not like a single sequence. This is a key value pair. So you have to say for the key, comma, the value, because the key value pair, okay, and now this thing is called quax. It's called quax. Let me make it lowercase here. Sorry. In quax, because quax is the dictionary now. So this, all right. We said the single star ax, the star ax, turns it into a sequence. What type of sequence does it turn it into? The star ax. What type of sequence does it turn it into? Who remembers? When we're dealing with the first, it turns it into a tuple. Okay. Now the double star quax turns it into a dictionary, not a tuple. So we deal with tuples and dictionaries. Now you know that if you are dealing with a dictionary and you want to do a loop, you know that there is a key aspect and a value aspect. So if you want to write a loop statement that will extract both the key and the value, you need to use two variables because you want to store in each iteration, you want to store the key and the value separately. You are free to name them whatever you want, but just for convention's sake, we can use how everybody does it in the Python community. But when you come here, you can't just call quax. You can't just call the dictionary like that. You have to say dot items. Because if you don't say dot items, you are not going to get the key and the value. Because a dictionary has multiple methods here. We have dot value. You see dot values. Dot values here can be used to create a loop in a dictionary, but it will only extract the values. So you don't need two variables here. You only need one variable. Only need one variable. Then we also have dot keys. You see, if you do dot keys, what it means is that you only need one variable because you are going to get only one item. But since it's a key value pair and you may want the double items, you have to also provide two variables for it to be spread or splitted across them. All right. So over here, if you want both the key and the value during the loop, which method do we use? Specifically, which method do we use to get both the key and the value? Which method do we use? Which method do we use? Which method do we use? Anybody? Which method do we use? So this is dictionary now. We use dots, not dot. Okay, excellent. Thank you. Just like that, dot items. All right, perfect. Thank you. All got it right. So if you said dot keys, the dictionary will only loop over the keys. If you said dot values, the dictionary will loop only over the values. You're not going to get both of them. But if you want both, you have to use dot items. So because of dot items, we can go ahead and do whatever we want. Let's print the keys and the value. So we can say print f strings. We can print the key and let's put comma. Sorry, let's put whatever and then you say value. Let's see what we'll get. All right. Okay, so let me go ahead and print this now and see we have, let me use this name, age, and country. So name, I'm going to use Dorcas. Age, I'm going to use 16. And country, I'm going to use Dorcas. Are you from Ghana? Ghana. Yes or no, Dorcas? Thank you. So you can see what we just did. Okay, name, Dorcas, age 16, country, Ghana. So there are some Python programs that you will create that requires the user to input multiple keyword arguments. Multiple keyword arguments. The dot capitalize that we saw here was just to capitalize the key. So it means it should turn the first letter to capital. That's all. All right. So this is an introduction to the double stack Quarks. And I know you have picked some foundational information from here. Next time when you encounter it, you'll move to the next level. The very last thing I want to talk about here is a signature of a function. Every function has a signature. And usually we do this in the Jupyter environment to test the signature of functions. Usually we do this in Jupyter environment, but we can also do this in a normal Python scripting environment. But let's see how it works in the Jupyter environment. So let me just launch Jupyter and open to my terminal and type Jupyter Lab, and my Jupyter Lab will run. And the moment the Jupyter Lab runs, what is going to happen is that you are going to be able to see. Yesterday, we created a machine learning model here. That was so nice. You can call any function. So let's define a function here, def, and call this function. Let's call this function greeting. All right, greeting. And let's give it, sorry, let me zoom for you. Greeting, let's give it a message and let's give it a star axe. Look at how we are defining it. All right. Then here, what we will do is to create a loop and say for over here in this particular loop, we are going to loop through the axe. So this axe, let me call it names. Okay. So we say for name in names, for name in names, print in F strings. Okay. Print the message, comma, and then print the name. All right. This is a simple Python function. Okay. Now, let me introduce a docstring here. You can see that most of my Python codes, I didn't use a docstring. And say that this function is able to give a special message to each person. Fine. Now, everything you see here is part of the definition. Let's run this, and the function is now created. We can call this function here. Let's call the function here. And in calling it, the function is called greeting. So we can call greeting. Sorry. And we will provide a message, welcome. Welcome. Let me put, it's not even necessary. Let me remove it. I don't want it. Welcome. And let me put the names. I can see we have Louisa. We have Dorcas. We have Francis. We have Benedict. All right. So we did something like this previously. And what this means is that the first one will be assigned to this, and all the names will be assigned to this one. Now let's run this. And you can see that it was able to welcome everyone. No problem. But one day, what can happen is that this greeting, we can ask it to give us its signature. Anytime you type the name of any function, whether you created it or it is inbuilt, and you add question mark and you run it in a Jupyter cell, it is able to fetch the signature for you. This signature is telling me that this particular function, this is how the engineer or the creator created it. He even added a docstring. You see, and it's of type function. Okay, this is interesting, but we created it, so we know. Let's take the print function that we didn't create and then do the same thing to the print function. If we do the same thing to the print function, we are going to be blown away. The print function has a signature. I don't know if you are seeing this. Look at how interesting the print function is. Wow, we have a lot to learn. You can see that the print function uses star axe. Okay, so the star axe we learned about today, the print function uses it. Okay, so this is why somebody can call print and add comma and something else and comma and something else and comma. This is why the print function never gets tired how many comma you add, because it is star axe. But it also has keyword arguments that you can specifically target, like SEP. And SEP is empty space, and is a new line character. It has file equals to none and flash equals to false. In our previous lessons, I'm sure you remember how we actually worked on this, actually called the SEP and we worked on it. All right. This means that anytime you call the print function to print anything, let's say print, let me put some names in here because it is star X. Let me put the same names here. Let's say Louisa, comma, Dorcas, comma, Francis, comma, Bernardine. All right. So the print function is able to do its job by printing whatever you give to it. And the comma here is a normal separator. Okay, the space I provided here doesn't matter at all. It's nothing. It's nothing. The comma is a normal separator, and we will still have spaces in the names, even though I didn't provide any name here, any space here. But we have discovered that there is space here because the Python signature has a SEP variable with space. So anytime you introduce a comma to add more items into the star X, you can use the SEP and call the SEP as a keyword argument and introduce your own separator. So if I introduce question mark, what will happen is that instead of space, it will use question mark. If I clear it and I say SEP is nothing, when you run it, SEP becomes nothing. So this time there is no space. Each print statement also has a new line in it. So it has a keyword called end. Now, these are default parameters. This is why even if you don't call them, they work because they are default parameters. So when you call multiple print functions, like, let me use Marianne, and let me use Lucretia. Sorry. All right. When you run this, the Marianne and Lucretia will join a new line because by default, anytime you call print, anytime it is done working, it adds a new line character at the end. The next print will definitely fall on a new line. But you can come here and control it. You can call the end parameter and say it should be nothing. This time when we run it, the new line will not work because we have controlled it. This is default parameters. If you provide something, what you provided is what will work. If you don't provide anything, the default will work. This is very clear. So we understand how to call the signature of a function in Jupyter Lab environment. Now, what I want to show you here, very interesting. The signatures of a function, the signature of a function tells you how to use the function, what its name is, and what input parameters it takes. This can be done to any function. And if there are any default values or types, they will also be displayed. So you can view the signature in IPython or Jupyter environment. So any interactive Python environment, it will work. Any IPython environment, it will work. But watch this. In your normal Python scripting environment, you can import a module called inspect and call inspect.signature and put any function here. So we can go to Jupyter, sorry, we can go to PyCharm and import inspect. Then this inspect, we can say inspect dot signature. Then you can put the name of any function. Let's try the print function again. This time, don't add the parentheses. Just like when I was adding the question mark, I didn't add parentheses. The question mark is used in IPython environment or JupyterLab environment or Jupyter Notebook environment. But this signature from inspect can be used in any Python scripting environment. And when we run this, we are going to see the signature of the print function here. I think this is beautiful and this is very, very interesting. All right. If you have any question, feel free and ask. And if there's no question, this is where I officially end this lesson on functions. This lesson has allowed us to explore functions and to talk more about it. And I believe our understanding of functions has gone higher. Our knowledge of functions has been improved. Over the past 2 weeks, I think what we knew about functions is better. So my question for you is that in this lesson tonight, have you learned anything at all? Anything new in this lesson? I just want to know. I just want to know. Wow, wow, wow. Thank you, thank you. A lot of responses. Thank you, thank you, thank you. I'm super excited. All right. So this is where we draw the curtain. Keep learning, keep learning, keep learning, because the future is bright and you are crafting a beautiful future. And very soon, your life will never be the same again. We are going to be seeing you at wonderful places, and you are going to make a lot of impact in Africa and the world. Thank you all so much for joining, and I will see you in the next class. I wish you all the best. Have a good night, and bye-bye.